Okay. Now in the next block, we are going to talk about the dual alternative decision structures, which is nothing but instead of having just a single path, that is, if the condition is true, do this, you are also allowing a false case. So if this is not true, then maybe do this. So such type of statements, like when you are having a false statement, you'll be using the block else. So if this condition is true, then the statements underneath this else if block will be executed. If this condition is false, then the statements underneath the if block will be skipped and the interpreter will move to the else block and will execute all the other statements which are underneath the else block. Notice the indentation, the if and else are in the same line, and the statements underneath the if block and the else block are indented similarly. So you have to make sure that if and else are aligned and all the statements must be consistently indented. So the structure is as follows. So if this condition is true, only then the statements underneath this the if block will be executed. If this condition is false, then the statements underneath the if block will be skipped. The interpreter will jump to else block and the statements underneath the else block will be executed. So let's take this example again. If this temperature is less than 40, if it is true, then you are printing the statement that says a little cold, isn't it? If it is false, then you are printing nice weather we are having. So if the temperature is in fact less than true, that is, if this condition is true, then only this statement is executed and the block, that is else block or the false condition, will be skipped. If this condition is false, then the true block will be skipped. The false block will be executed. So this is the flow again. So if this condition is true, then the statements underneath this block are executed, else the statements underneath the else block are executed. The control will jump here. If this condition is false, then all the statements inside the if block will be skipped and the interpreter will move to the else block and all the statements underneath the else block will be executed and the control will jump here. So after the statements are executed, it will follow the rest of the program if there is any. So indentation with an if-else statement, we have to make sure that if-else are aligned, and also the statements underneath each block must be indented consistently as well. So till now we have discussed about numbers, like if temperature is less than 40 or if it is 5 is greater than 3 or if A is greater than B. But how about when you are trying to compare strings? So strings can also be compared by using the equal to and the not equal to assignment or relational operators. So, and we'll see the example as well. And string comparisons are case sensitive. So this is same for all the keywords and all the variables in Python. So when you have a capital T and a lowercase t, or an uppercase t and lowercase t are not the same. So that is case sensitive. So strings can be compared by using all the relational operators. So greater than, less than, greater than or equal to, less than, and equal to. So we will be following the ASCII standards as discussed in chapter 1 to compare the strings. And if shorter word is a substring of the longer word, then the longer word is greater than the shorter word. So for example, so when you to describe what a substring is nothing but the data that has been taken from the original word. So for example, let's say you have the word strings. From here, ring, which is also a word, ring, is a substring of the word strings. So when you are comparing strings and ring, you do know that as ring is a substring of strings, strings is greater than ring, right? You're just adding, or you're just including more alphabets in your word strings, and which has less alphabets when it's compared to ring, which is a substring of strings. So let's take this example here. You have Mary, you have Mark, and these are the ASCII values with respect to Mary and Mark. Notice MAR are all the same. Y is different, K is different. So with that, if you are checking if name 1 is equal to name 2, the condition will be false, right? Because Mary is not equal to Mark. So which statement will be printed from this block? The else statement, that is names are not the same, will be your output from this program. And you don't have to remember the ASCII values for the strings or the alphabets. The program will do it for you. So basically the interpreter will do it for you. So we do know this, the uppercase characters A through Z are represented with numbers 65 and through 90. And then the lowercase A through Z are represented with numbers 97 and 122. Zeros, when the digits 0s and 9 are stored in as characters, they're represented by numbers 48 through 57. For example, string ABC 123 would be stored in memory as the codes. A is 97, 98, 99. 1, 2, 3 is 0 is 48. So 1 is 49, 50, 51. A blank space is represented by the number 32. You don't have to memorize all of this. Just if you could, it's good. Otherwise, it's still fine. So when we are talking about dual decision structures, we can also talk about nested decision structures. That means a condition can have multiple subconditions, so that the structure will be if, elif, else. Elif is else if, so it's when it's combined, it is elif. So this is basically a decision structure inside a different decision structure. So this is commonly needed in programs. So for example, let's take a look at this. So you're determining if someone is qualified for a loan, they must meet to these conditions. First condition is they must earn at least 30,000 per year. So that is earning or salary should be less than or equal to 30,000 or must earn at least. So 30,000. Next, must have been employed for at least 2 years. So you will be having employment or years is greater than or equal to 2. Here, this could be greater than or equal to 30,000 as well. So when you are working with such programs, instead of checking the two conditions simultaneously, you can check the first one. And if that is false, then there is no point in checking the other one, right? Because here we are determining if someone is qualified for a loan only if the person is meeting these two requirements. So they have to meet these two. So it is basically 30,000 and less than or greater than at least 2 years. So if that condition was just an or, so if the requirements were the person is qualified for a loan, if the person is at least meeting one of these conditions, in that case you could check simultaneously. But here in this case, as it's saying that both the conditions must be met, you can check the first condition, that is at least 30,000 per year. And if that is true, then you are checking for the second condition. Otherwise, you can just skip the second condition. So this is a flowchart representation. You are checking for the first condition, salary is greater than or equal to 30,000. If that is true, then you are checking for the second condition, that is years on job is greater than or equal to 2. If that is true, you are saying you qualify for the loan. Otherwise, false, you do not qualify for the loan. If the first condition itself is false, then you are not even checking for the second condition. You're just directly printing, you must earn at least 30,000 per year to qualify for the loan. So here it is very important to use the proper indentation. It is important for the interpreter, otherwise it will not be executed. And also it helps for the others to read the program, and it is much more readable as well. So we do know that else clause must be matching with if clause, and all the statements inside these blocks should be consistently indented. So here is the structure for if, elif, else. So if condition 1 statements, so this is when you have more than 2 conditions. So in the previous case, you have the first condition if, else, and then if, then you're printing. But otherwise, if you have more than 2 conditions, in that case, you could just use if, elif, else block. So that is if condition 1, checking the condition, and then statements underneath this condition. Elif condition 2 statements, elif condition 3 statements, else statements. You can include as many as elif statements that you would like underneath or after the if block, but you must end, like it is a good practice to end that by using the else block. There is a missing colon here, so I'll have to fix that. I'll fix that in the slides. So if this condition is true, only then you are checking for the second condition. Otherwise, you can just move on. That is from the previous case. But here, if this condition is true, then these elif blocks are skipped, and the else, if elif-else blocks are skipped, and the program is moving on to the rest of the flow. If this condition is false, then it is checking for the condition true. The condition 2. If this condition is true, then condition 3 and the statements underneath the second elif block are skipped, along with the else block are skipped. So the statements after this structure will be printed. Same, if condition 2 is false, then the condition 3 is checked, and if condition 3 is checked, then the statements underneath the condition 3 are executed and the else block is skipped. If the condition 3 is also false, then the statements underneath the else block are executed. So alignment with if, elif, and else are all aligned. So notice that if, elif, else are all aligned, and all the statements underneath these blocks must be indented consistently. Okay, so let's take a look at this. So if score is greater than or equal to 90, then you're printing your grade is A. Otherwise, you're checking if it is less than or equal to 80. If this is true, then it is B. If this is false, then check for 70. If that is true, it's C. If it is false, check for 60. If that is true, it is D. Otherwise, it is F. So this is your last else block from here. That is, you're just printing the condition, printing the statement, that is, your grade is F. Okay. So before we move on to the logical operators, we'll end this here, and then I'll discuss about logical operators in the next video.